Section 5.3 is about the double angle and half angle formulas. Again, the formulas in this section can be found on the formula sheet. You do not need to memorize these this semester. Let's start with the double angle formulas. Sine of 2x is equal to 2 times sine x cosine x. Next, we have cosine 2x. There are three possibilities you can use for solving, depending on the information given in the problem. So, cosine 2x is equivalent to cosine squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 times cosine squared x minus 1. Tangent 2x is equal to 2 times tan x, all divided by 1 minus tan squared x. Let's take a look at a quick example next. If cosine theta is equal to negative 3 over 5 and theta is in quadrant 3, find sine 2 theta. So first thing I'm going to do is draw a picture of what I have. So my angle is in quadrant 3, and I'm told cosine theta is negative 3/5. Alright, and I'm looking for sine 2 theta. So again, my formula for sine 2 theta is going to be 2 times sine theta cosine theta. Alright, well I got cosine theta, but I'm missing sine theta, so I need to figure that out. So again, my formula for cosine is x over r. So I know my x value is negative 3, my r value is 5. I'm missing what my y value is, but I can use the formula x squared plus y squared equals r squared. So let's plug in. I have negative 3 squared plus y squared equals 5 squared, so that's 9, plus y squared equals 25. Subtracting 9 to the other side, I get 16, and therefore y is square root of 16, which is 4. Now normally it's plus minus, right? But remember, we're in quadrant 3, and in quadrant 3, my y value is negative, so I want the negative 4 for this particular problem. Alright, and so I'm missing sine, so sine theta is equal to negative 4 over 5, right? Y over r. Alright, so now I can plug that in. Let's see if I can squish this in. So I have 2 times sine theta, which I just said was negative 4 over 5. And cosine theta was given in the problem. That was negative 3 over 5. Alright, multiplying, anything cancel out? No. So multiplying straight across, a negative negative means my answer is going to be positive. Let's see, on top, 4 times 3, 12 times 2, so that's 24 over 25 as my final answer. Next, I have the power reducing formulas to mention, and that is sine squared x is equal to 1 minus cosine 2x over 2. Cosine squared x is equal to 1 plus cosine 2x over 2. And tan squared x is equal to 1 minus cosine 2x all over 1 plus cosine 2x. The purpose of these formulas is to express either sine squared, cosine squared, or tan squared in terms of trigonometric functions with powers not greater than 1. Next, we have the half angle formulas. That is sine theta over 2 is equal to plus minus big square root 1 minus cosine theta over 2. Cosine theta over 2 is equal to plus minus big square root 1 plus cosine theta over 2. And tan theta over 2 has a couple options again on this one. So we have plus minus big square root of 1 minus cosine theta over 1 plus cosine theta, or sine theta over 1 plus cosine theta, or 1 minus cosine theta over sine theta. Now, the sign, you notice there was a plus or minus sign in front of the square roots. All right, that plus or minus sign is going to depend on which quadrant theta over 2 is actually in. So let's take a look at an example of what I mean by that. Let's use the half angle formula to find the exact value of cosine 165 degrees. So of course, if we look on the unit circle, we don't have 165 degrees. It's kind of one of our key points we have memorized. So we're going to rewrite that as equivalent to cosine 330 divided by 2. And now following the formula, I would have big square root 1 plus cosine 330 all over 2. And now I wrote the solution out as minus, but why am I going to choose to use the negative versus the positive answer? Well, let's look over here and scratch work on the right. I mentioned 165 degrees would be in quadrant 2. And since we're finding the cosine value, in quadrant 2, cosine, or my x value, has to be negative. So that is why I'm choosing to use the negative answer right there. From there, I'm going to go ahead and simplify. So I'm going to have negative big square root 1 plus root 3 over 2 over 2. And then I kind of have a baby fraction within a big fraction. So I'm going to go ahead and simplify that by multiplying everything, so top and bottom, by 2. And so then I'm going to have negative big square root 2 plus root 3 over 4. And then I can go ahead and separate that big square root sign by putting a square root on the top and a square root on the bottom. So I just rewrote that. So I got negative square root 2 plus root 3, all divided by square root 4. And since square root 4 is a perfect square, I can simplify one more time, and I got negative square root 2 plus root 3 all over 2. Again, please be sure to check out the Canvas notes for more examples.